So we're going to create a vehicle class, and then we're going to instantiate a vehicle object, and we're going to use some of the functions that we're going to be generating. All right, so the first thing we're going to do is use the keyword class, and then we're going to give the class a name. We'll call it vehicle. And from there I need an opening curly brace, and notice it gave me the closing brace. Already has the semicolon on it. That's very nice. So we're probably going to want some variables, and we're probably going to want some functions, right? Now, as a general rule, all of the members of the class are they private, public, protected? What do you think? Yes, they are private. But we're going to include the word private. And if I wanted to move between private and public among the members, I could just use the keyword private again. So we're going to create some private variables. I distinctly remember that there were 5 variables. There were 4 strings. The vehicle has a make, a model, a year, and a color. And then there was one floating point, which was going to be the odometer. So let's create those. So I'm going to declare them all on the same line. The string variables all on the same line. You're more than welcome to declare them on separate lines. There were 3 functions that we were going to create. One was initialize. One was grow. I'm pretty sure that we were going to grow the mouse. We were going to, we were going to drive. I'm getting ahead of myself. We were going to drive the vehicle, and then the last one was to print a vehicle. So these are the 3 function declarations that we're going to create in here, and then we're going to go outside of the class and we're going to give those definitions. Our initialize function is going to set the variables to a value. The drive is going to increase the odometer. And the print vehicle, well, the print vehicle is just going to display the vehicle. All right, so let's do a function declaration for initialize. It's going to be void. We'll call it initialize. And we are not going to have any parameters or arguments. The drive will also be void. We'll call it drive. They are going to have to tell us how far they want to drive. So we're going to have some kind of a parameter called miles. And then the last one is to print the vehicle. That will also be a void. It doesn't return anything to me. We'll call it print vehicle. And then we're just going to decide what we want that vehicle print to look like. What do we want it to display as? So we're going to create the definitions for the 3 functions. The first one is initialize. It's going to be void. Initialize, we're not going to have them pass anything to it. Instead, we are just going to initialize it. We'll have our opening and closing braces. And what I'm going to do inside of here is I'm going to set, let's say, for instance, I'm going to set the make to Subaru. Oh, that's an excellent make for a vehicle. We do have to put the name of the class. And so our class is called vehicle. And then the 2 colons in order for it to recognize that the function declaration is in the class. And so we are defining a function in the class. And so I'm going to set the other 4 variables to something. So my vehicle is going to be a Subaru Outback 1999. It was a limited edition, white and gold with dual sunroofs. And I watched it roll 200,000 miles. It was a wonderful car. So that's what I'm going to initialize my vehicle to. You might choose to use something different. All right, so let's come down here and let's define drive. So drive will not return anything to us. So we're going to have to make it of the vehicle class, if I spell that right, and we're going to call it drive. Now, somebody is going to have to pass us a floating point. I might name that parameter miles. I need my opening and closing brace. And then in here, this drive function, I do want to make sure that they're not trying to roll back the odometer. So this is an example of a setter because I'm going to be setting my odometer. but I'm going to add a constraint to it that says I'm only going to add it to the odometer if the miles is greater than or equal to 0. So they can do 0. I guess if they want to let it sit over a holiday weekend, they can drive 0 miles, but it has to be greater than or equal to so that I'm not rolling back the odometer in negative mileage. All right, so the last thing that we want to do is the print the vehicle. And what I would really like it to say is something like 1999 Subaru Outback. And then we'll say, white Subaru. That would be a white and gold Subaru Outback with 200,000 miles on it. So I'm going to see if I can build this print statement. All right, so I did the function declaration on line 53. I have the function header there. And then on line 54, I built that print statement. I did add a miles to the end of it so that it reads a little bit more. And then we're going to come down here to main, and we're going to instantiate objects of the vehicle class. So because they're of the vehicle class, I'm going to call it, how about if I call it my car? And then we're going to see if we can initialize my car. So I'm going to use the class object with a .access operator, initialize, and it is a function, and it looks like it's not happy with that function. So let me hover over it, and it tells me that it's not accessible. So if you remember, we talked about accessibility of the members and that the class members are automatically private. That is the default value for the private. I did use that private keyword anyway, but if you'll notice the functions, everything following that keyword are going to be the same. I need the functions to be public. So I'm going to change this keyword to public. And then as soon as I do that and I come back down here, it should initialize my car, and then let's print it. So I want to print my car, which means I'm going to use that object to call the function. And now Visual Studio is nice enough to give me a drop-down list of accessible functions and variables for that matter if I had any. So let's see if we can print my car. There it is. It's a beautiful car. Just a beautiful car. Let's create another one. So I'm going to come in here in the declaration, my car. How about if we create your car? And then how about if we create NASCAR? We'll just have 3 of them and we'll see what we can do. So I'm going to say your car. We'll say dot initialize. And then we're going to drive it. Your car dot drive. So how about if you're going to go on a road trip, right, for the holidays? So we'll drive it 1,200 miles for the road trip, and then we'll display it. So print vehicle. Oops. Oh, it was nice enough to give it to me. There we go. So when we run this, let's see if it will actually increase your vehicle mileage by 1,200 miles. There it is. So you have 201,200 miles. Apparently I can't read numbers. So we have one more car, just one more car. NASCAR. How about if I say NASCAR dot, let's just print it. What happens if I just print NASCAR? It's giving me some very, very strange values. Can anybody tell me why? Or does anybody know why? If you said because we never initialized it, you were absolutely right. We never initialized a NASCAR to any particular values. So how about if we overload initialize? Because I know how much fun that you are having with your Subaru Outback, right? But actually what we're going to do is we're going to overload this. So I'm going to steal this function definition. And remember, in order to overload, we're going to overload a function, any function. How do we go about overloading a function? Well, it seems like there's going to have to be something different about the parameter list. So if this has no parameters, this is going to have some parameters. So we're going to overload it in order to set some initial values, so it doesn't have to be a Subaru Outback. We're also going to have to come up here and overload this initialize here as well. So I'll say that we're going to overload this one as well, and we're going to pass some parameters to it. It looks like in order to do that, we are going to need a string make, a string model, a string year, color, and then finally it is a float, which is a short double. A short double. So we need to overload the initialize function as well. And we'll come back down into our overloaded initialize. And what we need is, as a matter of fact, I'm going to come up here to this parameter list, and I'm just going to steal this whole entire parameter list. And I'll paste it down inside of this parameter list right here so that we can overload the initialize function. Now, this is the parameter make, and what I want to do is I want to set my class variable make to the parameter make. So if I say something like make equals make, it seems like that would be very confusing, right? How does it know which one of the makes is which one of the makes? So I'm going to use a this keyword to indicate that this is my class variable called make, and this is my parameter. And I'm going to do the rest of them. This model, we'll use like an arrow for this model, equals the parameter model. And then I'll come back here and I'll change the rest of them. So if I had chosen to call this parameter something else like miles instead of odometer, then I'm not to have to indicate which one is the class variable and which one is the parameter. I could just say odometer equals miles because it's clear which one is the class variable and which one is the parameter. But if I'm going to use the same names for my parameter as I have for my class variables, I need to use this keyword so that the compiler will know which one of the two are the class variables compared to the parameter value. All right, so let's initialize your vehicle, because I'm pretty sure you probably don't want your vehicle down here to be a Subaru Outback. So I'm going to have to pass some arguments to it, 5 arguments. Make sure that I have it in the right order with the make, model, year, color, and miles. And if I initialize or use those initial values in the initial, you can hard code 4 strings and a floating point. And then we're going to drive it and we're going to print the vehicle using our overloaded method called initialize, and there it is. We still have our Subaru Outback, but now we have your awesome and amazing fire engine red Nissan Sentra. So now that you've had a chance to create a vehicle class and use that class to instantiate vehicle objects and to access some of the functions that are available to it, it's your turn. What I want you to do is add a couple new variables to our vehicle class because, well, vehicles get in accidents. So I want you to add two variables to the class. A Boolean variable for accidents, and then an int for the number of accidents that the vehicle may have been in. In order to be able to do this, you're going to have to overload the initialize function to include the 2 new variables, or to give default values to the 2 new variables. And then you're going to have to overload the print vehicles in order to be able to display our 2 new vehicles. Then I want you to add instructions to main to test out your overloaded values. As always, I want you to include inline comments and test cases.